Dear students, welcome to our series on geography. We all exist on earth due to natural elements like water, sunlight, air and vegetation. Air is vital for our existence. We feel and sense it but never give much thought to it. Amazingly, the air around us has many interesting characteristics like weight, moisture, temperature, pressure and so on. In today's episode, let us understand about atmospheric pressure under the following subsegments: meaning of atmospheric pressure, changes in air pressure, low and high pressure areas, effects of changes in air pressure and air pressure and wind. Firstly, meaning of atmospheric pressure. Atmospheric pressure is the force per unit area exerted against a surface by the weight of air above that surface in the earth atmosphere. In most circumstances, atmospheric pressure is closely approximated by the hydrostatic pressure caused by the weight of air above the measurement point. Low pressure areas have less atmospheric mass above their location, whereas high pressure areas have more atmospheric mass above their location. Similarly, as elevation increases, there is less overlying atmospheric mass, so that pressure decreases with increasing elevation. A column of air 1 square inch in cross section measured from sea level to the top of the atmosphere would weigh just over a stone. Just answering the question what is atmospheric pressure is not enough to give a full understanding of its importance. By definition, atmospheric pressure is force per unit area exerted against a surface by the weight of air above that surface. Atmospheric pressure is closely related to the hydrostatic pressure caused by the weight of air above the measurement point. The term standard atmosphere is used to express the pressure in a system and is equal to 101.325 kilopascal. About 80% of the Earth's atmosphere is contained within the troposphere, the part of the atmosphere that is closest to the Earth. The extent of the troposphere varies by latitude. It is thickest over the equator and thinnest at the poles. Air pressure is the force exerted on you by the weight of the tiny particles of air. Although air molecules are invisible, they still have weight and take up space. Since there is a lot of empty space between air molecules, air can be compressed to fit in a smaller volume. When it is compressed, air is said to be under high pressure. Air at sea level is what we are used to. In fact, we are so used to it that we forget we are actually feeling air pressure all the time. Weather forecasters measure air pressure with a barometer. Barometers are used to measure the current air pressure at a particular location in inches of mercury or in millibars. A measurement of 29.92 inches of mercury is equivalent to 1013.25 millibars. Now, let me tell you how much pressure we are under. Earth's atmosphere is pressing against each square inch of us with a force of 1 kilogram per square centimeter. The force on 1000 square centimeters is about a ton. It is also surprising that even though all that pressure crushing us, we stay stiff. We should remember that we all have air inside our body too. That air balances out the pressure outside, so we stay nice and firm and not squishy. changes in air pressure. If you have ever been to the top of the tall mountain, you may have noticed that your ears pop and you need to breathe more often than when you are at sea level. This is because as the number of molecules of air around us decreases, the air pressure decreases. This causes our ears to pop in order to balance the pressure between the outside and inside of ear. Since we are breathing fewer molecules of oxygen, we need to breathe faster to bring the few molecules there are into our lungs to make up for the deficit. Pressure varies smoothly from the Earth's surface to the top of the mesosphere. Although the pressure changes with the weather, NASA has averaged the conditions for all parts of the Earth year round. As altitude increases, atmospheric pressure decreases. One can calculate the atmospheric pressure at a given altitude. Temperature and humidity also affect the atmospheric pressure, and it is necessary to know these to compute an accurate figure. At low altitudes above the sea level, the pressure decreases by about 1.2 kilopascal for every 100 meters. Local atmospheric pressure variation. Atmospheric pressure varies widely on Earth, and these changes are important in studying weather and climate. Atmospheric pressure shows a diurnal or semi-diurnal cycle caused by global atmospheric tides. This effect is strongest in tropical zones with amplitude of a few millibars and almost zero in polar areas. There is a relationship between boiling point of water and atmospheric pressure. Clean fresh water boils at about 100 degrees centigrade at Earth's standard atmospheric pressure. The boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure around the water. Because of this, the boiling point of water is lower at lower pressure and higher at higher pressure. This is why cooking at elevations more than 1100 meter above the sea level requires adjustments to recipes. Coming to low and high pressure areas. Air pressure is not uniform across the Earth. The normal range of Earth's air pressure is from 980 millibars to 1050 millibars. These differences are the result of low and high pressure systems which are caused by unequal heating across the Earth's surface and the pressure gradient force. A low pressure system or lows is an area where the atmospheric pressure is lower than that of the area surrounding it. Lows are usually associated with high winds, warm air and atmospheric lifting. Because of this, lows normally produce clouds, precipitation and other bad weather such as tropical storms and cyclones. In addition, areas prone to low pressure do not have extreme diurnal nor extreme seasonal temperatures because the clouds present over such areas reflects incoming solar radiations back into the atmosphere, so they cannot warm as much during the day, and at night they act as a blanket trapping heat below. Conversely to low pressure area, a high pressure system or highs is an area where the atmospheric pressure is greater than that of the surrounding area. In some places, highs are referred to as anticyclones. These moves clockwise in the northern hemisphere and counterclockwise in the southern due to the Coriolis effect. High pressure areas are normally caused by a phenomenon called subsidence, meaning that as the air in the high cools, it becomes denser and moves towards the ground. Pressure increases here because more air fills the space left from the low. Subsidence also evaporates most of the atmosphere water vapors, so high pressure systems are usually associated with clear skies and calm weather. Unlike areas of low pressure, the absence of clouds means that areas prone to high pressure experience extremes in diurnal and seasonal temperatures, since there are no clouds to block incoming solar radiations or trap outgoing long wave radiations at night. Thus, such areas have higher high temperatures and lower lows. Across the globe, there are several important consistently low and high pressure areas. They are as follows: the equatorial low pressure throat, the subtropical high pressure cells, subpolar low pressure cells and polar high pressure cells. Coming to effects of changes in air pressure. Increases in atmospheric pressure results in a condition called ear popping, where air particles rushes into the ears to balance out the pressure inside and outside of the ears. This may result in pain for some people. Other health effects of high pressure, such as that during diving, could be found at effects of hydrostatic pressure on the human body. Everyone breathes faster and deeper at high altitude. It is necessary to do this in order to survive. The function of the lungs is to expose blood to the fresh air, and breathing faster essentially increases the flow of fresh air past the blood. This means that whenever an oxygen molecule is taken away by the blood, it is quickly replaced by a fresh one. This means that there is always more oxygen available to be taken up into the blood. When the atmospheric pressure drops, tissues expand. The expansion of tissues in and surrounding joints aggravates the nerves, causing pain. Thus, patients living in geographical locations with a higher atmospheric pressure tend to experience a greater severity of osteoarthritis. Drops in atmospheric pressure also have an impact on headaches, particularly sinus headaches. When atmospheric pressure drops, gases in the sinuses and ears are at a higher pressure than those of the surrounding air. The air pressure tries to equalize, causing pain in the face and ears. The effect of high altitude on humans are considerable. The percentage saturation of hemoglobin with oxygen determines the content of oxygen in our blood. After the human body reaches around 2100 meter above sea level, the saturation of oxyhemoglobin begins to plunge. However, the human body has both short term and long term adaptations to altitude that allow it to partially compensate for the lack of oxygen. Athletes use these adaptations to help their performance. There is a limit to the level of adaptation. Mountaineers refers to the altitudes above 8000 meters as the death zone, where no human body can acclimatize. Death zone. The death zone in mountaineering refers to altitudes above a certain point where the amount of oxygen is insufficient to sustain human life. This point is generally tagged as 8000 meter. The concept of death zone was first conceived by Edward Weiss Dunant, a Swiss doctor. Many deaths in high altitude mountaineering have been caused by the effects of death zone, either directly, that is due to loss of vital functions, or indirectly, that is by wrong decision made under stress, physical weakening lead to accidents. In the death zone, no human body can acclimatize. An extended stay in the zone without supplementary oxygen will result in deterioration of bodily functions, loss of consciousness, and ultimately lead to death. Coming to air pressure and wind. The wind blows because of differences in air pressure from one location to another. Wind blows from areas of high pressure towards areas of low pressure. If the high pressure area is very close to the low pressure area, or if the pressure difference is very great, the wind can blow very fast. Wind results from a horizontal difference in air pressure, and since the sun heats different parts of the earth differently, causing pressure differences, the sun is the driving force for most of the winds. The wind is a result of forces acting on the atmosphere. Many of the forces within our atmosphere are easily recognized by us. This is due to the fact that we can use our senses to feel these forces. For example, we can quickly determine the approximate temperature outside simply by stepping outside. We immediately know whether it is cold, warm or hot. Likewise, we can feel the amount of wind or see the level of windiness by looking at how forcefully the trees are swaying back and forth. Even humidity is easily perceived. This is not the case with pressure. Because wind is caused by the gases of the earth's atmosphere moving about in an attempt to equalize pressure, it seems natural to assume that wind would blow outward from areas of high pressure towards areas of low pressure. In a perfect world, free from other influences, this would indeed be the case. However, sometimes other factors can cause wind to blow differently than this expected pattern. Three important factors affect the direction that wind blows. These factors are pressure gradient, the Coriolis effect and friction. Pressure gradient. The force that causes wind movement results from horizontal pressure differences. It is the direction and magnitude of the pressure gradient which ultimately determines wind direction and its velocity. Wind moves from higher pressure to lower pressure. Thus, pressure differences cause the wind to blow, and the greater these differences, the greater the wind velocity. In other words, the interrelationship between gradient force and wind can be seen in the form of wind direction and wind speed. The Coriolis effect. The Coriolis force produced by the rotation of earth has its effect on every moving object, whether it is an ocean current or a bullet fired from the gun. Strictly speaking, Coriolis force is not a force in the true sense of the term. In fact, it is an effect which results from the rotational movement of the earth and the movement of air relative to the earth. The Coriolis force is 0 at the equator and maximum at the poles. It acts at right angles to the horizontal direction of the wind, and it is directly proportional to its horizontal velocity. In the northern hemisphere, the Coriolis force acts to the right of the direction of wind, and in southern hemisphere it acts to the left. That is why all winds in the northern hemisphere tend to move towards right and those of the southern hemisphere to the left with respect to the rotation earth. This accounts for the fact that in the northern hemisphere winds blow counterclockwise around the centers of the low pressure, but clockwise in the southern hemisphere. Coming to wind friction. The final major factor affecting the direction that wind follows is friction. Near the surface of the earth, there are many things that interfere with wind, slowing it down and changes its direction. These includes trees, mountains, houses, buildings, lakes, oceans and streams. Since Coriolis force is proportionate to wind speed, the friction consequently reduces it. On the contrary, the pressure gradient force remains unaffected by wind speed. Hence, it exceeds the Coriolis force along or near the earth's surface. This results in the movement of air at an angle across the isobars towards the low pressure area. Irregularities or roughness of the ground determine the angle at which the wind will cross the isobars while blowing from high to low pressure. It also controls the speed of wind. Friction is relatively lower over the ocean surface. The angle at which wind drifts across the isobars over the relatively smooth ocean surface varies from 10 to 20 degrees and the wind speeds are reduced to about 2/3 of the geographical flow uphill. Next is wind speed. Although occasionally other factors can impact the speed at which airflow travels, wind speed is primarily affected by the pressure gradient. If the pressure gradient is sharp, or in other words, if it changes rapidly from a high pressure to a low pressure, then the wind speed will almost always be high. If the pressure gradient is gradual, then in almost all cases the wind speed will be low. Circulation of the atmosphere. While wind direction and speed change from one moment to the next and from one location to the next, it is however possible to identify general patterns that affect the entire surface of the globe. This is especially true the higher one travels into the atmosphere. So, we can summarize the topic. The earth is covered by an atmosphere of gases which exert a pressure on objects situated within this gaseous envelope. The pressure is due to the mass of the gases which is attracted to the earth under influence of gravity. Atmospheric pressure is the weight of air over a given location. The amount of air pressure will vary depending on the area's altitude level and the weather. The pressure is measured by a barometer. The reading provided by the barometer is the barometric pressure. Studies have shown that barometric pressure has an effect on people. Blood pressure can be affected by different types of air pressure, especially at sea level. There are also cases wherein people experience discomfort when the barometric pressure goes down. A sudden change in barometric pressure may also cause headaches. When air pressure is attempting to equalize, pain may be felt in the ear or the face. People with chronic sinusitis are the most susceptible to ill effects resulting from air pressure changes. To say again, atmospheric pressure is essential for life forms to survive on the earth. Hope our program on atmospheric pressure was informative and useful. Please do send your feedback and join us again on our next episode on geography.